Hey guys, so today we're going to be looking at Aime 1984's number 5. So hopefully today we can learn more about logarithmic identities and use them to solve this problem. So determine the value of a times b if log base 8 to a plus log base 4 b squared equals 5 and log base 8 of b plus log base 4 of a squared equals 7. Okay, so here I wrote down some logarithmic identities. The first two written in purple should be quite familiar. Log base x of a plus log base x of b equals log base x of a times b. When we subtract it, log base x of a minus log base x of b equals log base x of a over b. So adding and subtracting logarithms should be quite self-explanatory. It's good to be familiar with these two because they're used a lot. Okay, so the next three written in green, we're going to actually use these mostly for the Aime problem that I had shown below. Just then, I mean. So, log base x of a to the power of r. When a has a power, that power becomes the coefficient of the logarithm. So this would become r times log base x of a. So if this was log base x of a root r. Obviously, a root r equals 1, a to the power of 1 over r. Therefore, 1 over r would become the coefficient of log base x of a. So in logarithms, what we do to the base also applies up here. So say, obviously, this is really complicated. Say we want to take this to the power of r. So let's take this to the power of r. Then we would also have to take x to the power of r. So log base x to the power of r, this would also equal 1 over r times log base x of a. So in conclusion, basically what we do to the top, we also have to do to the bottom, and it's going to be equal. Okay, so again, what we do to the top, we do to the bottom. Log base 8 of 27 equals log base 2 to the power of 3 of 3 to the power of 3. And because they're both cubes, we can cancel that out. And this would also be equal to log base 2 of 3. So it's really important to keep that in mind. So hopefully now that we're more familiar with logarithmic identities, we can actually move forward and solve this problem. So as you can see here, I added up the two equations. So all of this and this equals 12. I added them up because obviously, as you can see, this and this and this and this, log A, I feel like having the same base would be easier to work with. So we know that log base 8 of a plus log base 8 of b. When you add those two together, it equals log base 8 of a times b. And then obviously these two, log base 4 of a squared b squared. And this equals 12. Okay, so I underlined the 8 and the 4. Because a equals 2 to the power of 3 and 4 equals 2 to the power of 2. Therefore, it would be a lot easier if we converted these two to log base 2. So because 8 equals 2 to the power of 3, log base 2 to the power of 3 ab would equal 1/3 log base 2 of AB, because when we have an exponent in the base, we basically, the coefficient would be the reciprocal of that power. So we can add this log here, 2 squared a squared b squared. We have squared here, so we can cancel that out, plus log 2 base 2 of AB, that would equal 12. And so now this is just algebra. We add this up. 4 over 3 log base 2 of AB would equal 12. And so log base 2 of AB would equal 12 divided by 4 over 3, which is 9. So this is our final equation. We get that AB, AB equals 2 to the power of 9. Therefore, AB would equal, we're asked to find the value of AB. AB would equal 512. Thank you.